Hey guys, welcome back to my YouTube channel. So this is the one of the important problem that I got from the GATE question. So let's solve this question. From this we are winding up our entire discussion in the number system and all the logic and basic function like everything. So then tomorrow we will be starting with combinational circuits. So let's take the question. That let me use the red color pen. So here they given 4-bit gray code. So the number n is in 4-bit gray code. Okay. So let H3, H2, H1 be the gray code representation of number n. That is a normal natural number n. Means a normal decimal number. So G3, G4, G1, G0 which is the gray code representation of n plus 1 modulo 16 value of the number. So which one of the following function is correct? Okay. So they are giving something. So this is similar to the K-map, right? We will write like minterm. So they have asked the minterm to be done. So let me draw a table so that we can compare it perfectly. So this is for normal n. I will write a decimal things here. So here I will write the decimal gray code of the h thing, and there I will write a gray code for g. Okay, so I hope this will be fine. So let me separate it. Okay, so this is n. So let me write it 0 1 2 3 4 5 6 7 8 9 10 11 12 13 14 and 15. Okay, so here it is a gray code of normal number h3, h2, h1, h0. So you see it's a gray code of normal number n. So this one's gray code. Okay, so the normal 0 can be written as 0 0 0 1. The gray code is 0 0 XOR 0 0 0 0 0. Everything is 0. So here the gray code will be same. So 0 0 0 and 0. Okay, so let me use this for all things. So let me erase and rewrite it. So the 1 can be written as 0 0 0 1. So the gray code of this one is the 0 0 XOR 0 0 0 XOR 0 0. The 0 XOR 1 is 1. So okay, so this can be written as 0 0 0 1. Okay, for 2, so 2 can be represented as 0 0 1 0. So this is 0, so 0 1 and 1. Okay, so this is the gray code representation, that is 0 0 1 1. So I'm leaving this to you. Please fill the box. I am going to write every values. So 3 gray code is 0 0 1 0. So why it is gray code is, you can see there is only one bit change. So the first bit change, the second bit change, here again first bit change, right? So fourth one can be written as 0 1 1 0. Fifth is can be written as 0 1 1 1. 6 is 0 1 0 1. 7 is 0 1 0 0. 8 is 1 1 0 0. So 9 can be written as 1 1 0 1. So 10 is written as 1 1 1 1. So 11 can be 1 1 0 1. So 12 1 0 1 0. So 13 1 0 1 1. So 14 is 1 0 0 1. So 15 is 1 0 0 1. Sorry, 0 0 0. Okay, so now the next thing we have to find out G3, G2, G1 and G0. So they are given a hint that it is an n plus 1 modulus. So for an example, if you take the number 0, so number n is equal to 0, then the g function will be depend on n plus 1. So 1 modulus of 16 which is equal to 1. So okay, so it will be same as it is. So 1 modulus that will be equal to 1. So every number is increased by 1. So if you take 0, then the value of this need to be there. So for 1, so 1 gray code representation is the below. So just shift it, one shift is upward. So 0 0 0 1, right? So 2, if we take n is equal to 1, then the g value the 2. So 2's gray code will be this one. So just an upper shift. So let me fill the box like this. So 0 0 1 1. So I hope you guys understand. So the only change is when n is equal to 15, then the value will be g. So the vg is equal to 0. So the last, this will be upper shift, so that will come down. So okay, so let me fill the table. So for third one, that is 0 0 1 0. For this one, that is 0 1 1 0. So for this 0 1 1 1 0 1 0 1. So 0 1 0 0. For 7, that is 1 1 0 0 1 1 0 1. So next is 1 1 1 1 1 1 1 0. So next is 1 0 1 0. So next thing is 1 0 0 1, and the 14th one is 1 0 0 0, and the last one is first one's value. Okay, I hope you guys are able to get it right. So the thing is that now we have to find out the value of each one. So G, so let's take, here they asked everything, G0, G1, G2, G3. I hope this table is fine, right? So this is just an n plus 1 modulus. So n plus 1 modulus 16. So that is just a gray code representation of n. Okay, so this is very simple. So I think you hope to understand. So let's take the function of G0. So G0 as the function of G3, H2, H1, H0. So means that G0. So G0 is the last one, right? So this one. So let me take another one pen. So this last value. So let me take this. So this last value, whenever this last value is 1, we have to take the respective bit and we need to find out the decimal equivalent. So that is what the question that they are given. So let me find out the thing. So here if you see, the G1 is 0. So G1 is 1 at the position this one. So we have to take this one and we need to find out the decimal equivalent. So if we find out, then the first term will come as, so all 0, so that will start with the 0. But in the option if you see, there is no zeros given. So this is incorrect. So this option is wrong. So we can ignore option A. Okay. So let's take the next one. So which is, so let me take, I hope this one is understood, right? So this one is fine. So let me find out G1. So G1 as a function of H3, H2, H1, H0. So the same thing, whenever G1 is 1, we need to find out the equivalent decimal. So this thing is, the G1 is 1 here. So here it is 1. So this 0, 0, 1. So this decimal equivalent is 1. But 1 is having mentioned anywhere. So this is also wrong. So this is also wrong. Okay. So let's take a next thing. So that is G2. Okay. So let's take G2. So G2, which is function of this H3 to H1. So if you take G2, so G2 has this one. So this normal decimal equivalent, which is equal to 2. So this is 2. So if we see 2, so 2 is there. Okay, right. So next one, G2 is 1 at this one. So this one's binary equivalent is 2 plus 4, which is 6. So which is also here. So let me write all the thing and then we can replace it. So next one is 7. 7 can also be there. So next one is, this one is 5. So 5. So next one, this is also done. So this one is, I think this is 1, 2, 4. So next one is 4. Then next is 12. So this is done, this is done. So this is 13. And this is the last one. This is with the 15. I think I am alignment is there. So this is with there. I missed this alignment. So this is there. So this is 15. Okay. So here if you see, 2 is there, 4 is there, 5 is there, 6 is there, 7 is there, 12, 13, 15. So this option is correct. So let me check D also, the function of G3. So G3, which is equal to H3, H2, H1, H0. Okay, which is equal to summation of. So let's take wherever G3 is 1. So G3 is 1 from here. So this decimal equivalent is 1, 2, 4. So this is starting from 4. So and then this is 8 plus 4, 12. Then 13. This is 15, 14, 10, 11, and this one is 9. Okay. If you see 0 is presented here, but 0 is not coming. So this one is also wrong. So the only option correct is C. So I have mentioned you how to find all the G0, G1, G2, G4, everything I have mentioned. So if you guys have any doubt, please ping in the comment section. So this is one of the very important question. So please note it and please rewatch if you guys didn't understand. Even if you guys not able to understand, please ping in the comment section. So this is one of the very important question. There are a lot of logics has been present here. So I hope this is one of the informative video. So if you find it informative, please like, share and subscribe the channel. So stay tuned for more videos like this. So this is one of the very important 2 more question that is asked in GATE examination. So please like, share and subscribe the channel guys. So stay tuned for more videos like this. Okay, thanks.